Welcome to 24 Hours of PaaS Evolution of Data Platform. We are excited you could join us today for Reza Rad's session, Temporal Tables and their role in ETL and Data Warehouse. This 24 Hours of PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit www.24hoursofpaas.com for all sessions links. My name is Joseph Barth. I am the Arizona chapter PaaS chapter leader, and I have been working in SQL Server for many years. My focus has been on ETL development and SSIS in the last 4 or 5, so this talk will be great for me. I have a few introductory slides before I hand over the reins to Reza. Next slide. So for technical assistance, if you require technical assistance, please type your question in the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. That'll be at the end. You are able to zoom in on your presentation by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is very important to us. Please take a moment to complete it. It will appear in your web browser. So next slide, we would like to thank all the sponsors. Microsoft, Amazon Web Services, Hortonworks, and Redgate. In addition, I'd like to also thank the supporting sponsors for this event: Hewlett-Packard Enterprise, SanDisk, and SQL Sentry. SQL Sentry delivers software that optimizes the performance of SQL Server analysis service in Windows. They provide data professionals the ability to monitor, diagnose, and optimize SQL Server performance for on-prem, virtualized, and hybrid environments, including Microsoft Azure Data Platform. So the staging of 24-hour PaaS would not be possible without their generous support, and they are the reason this event is available for free. So don't forget about them. So a reminder: if you guys could please join PaaS, make sure you explore everything PaaS has to offer for data professionals. You can join local users group like what I lead, or they're all around the world. So special interest groups, find free online resources through our Learning Center, and read up on the latest community news and connector newsletter. So let me talk next about a little bit Reza Rad. He's a data warehouse BI consultant, mentor, and trainer. He is a SQL Server MVP. He also has authored a couple books, also webcast on Radicad. And then also he's been a trainer and a professional co-leader of New Zealand BI user group. I actually had the PaaS summit of last year. I got to actually speak with Reza Rad and meet him, so it's actually pretty cool that I get to moderate his session. So without further ado, Reza, here you go. Thank you.
Great. Thank you, Joseph. I have to especially thank Joseph. Hi, everyone. I'm Reza Rad. I have to especially thank Emilia, Angie for setting up these sessions back-to-back for 24 hours. That has been quite a lot of work. I've seen that how they worked from a few months ago, and it was extensive amount of work. Thanks for them. Thanks for the opportunity for me to speak. I've met also Joseph, as he mentioned, last PaaS summit when we played actually bowling, not pin bowling actually, it was kind of round bowls, and he's playing very nice. So if you had a chance to play with him, give it a try. That was my first time playing, so I wasn't playing that much good. Okay, let's start. This session is about temporal tables and their roles in ETL and data warehouse. So a little bit of, about agenda. Before going to that agenda, if you have any questions, just type your questions in the question bar. We will have a time about 15 minutes at the end for Q&A. So make sure you put your questions. Even if you don't have time to go through that, I will definitely post answers on my weblog later on. So agenda, I'll talk about introduction to temporal tables, which are new features in SQL Server 2016. Then I'll go through an overview of slowly changing dimension, things that are probably most of you already know, but I'll just go through them as a overview, as a kind of warm-up. And then I'll show you an example of implementing a slowly changing dimension currently with SSIS. This is just one of the examples of how you can do that. Then we'll go through a practice of a slowly changing dimension now with temporal tables with a new method, and you will see how easy it is to do that. Then I'll show you a couple of more usages of temporal tables, one as incremental load process, another as a rollback. And then we'll go through some consideration when you work with temporal tables. Right, first thing, why temporal tables? So temporal tables actually is created for some requirements. First is data audit. Most of the time you need to know actually what's happening on the data records that have been inserted, deleted, or updated, and the date and time that these happen, those kind of information. Another thing is time travel. So you would, most of people actually would prefer, most of businesses, most of requirements would prefer to have ability to time travel, to see, for example, what was their organization chart a year ago, what was their organization chart at year 2005. So this ability to going down to that level and seeing what was the status of the data, what was data records at that point of the time is really useful. And temporal tables is one of the things that answer this. Another thing is row-level error correction. So when you have temporal tables, which actually logs every insert, update, or delete, you can simply actually go to each row level and make a correction on that. And the last one, which will be mostly we talk about that in this session, is the slowly changing dimension, which actually is about applying changes in dimension attributes by this by a new structuring table. There are different types of slowly changing dimension, which I will go through that one by one. Temporal tables is definitely helping on that. Now, what is the temporal tables? Temporal tables are system version tables, and they are new features in 2016, SQL Server 2016. These tables actually consist of two tables. One is the main table, another is historical table. So main table keeps the most up-to-date records, and historical will keep deleted records, the records that has been updated and is now obsolete. These are all actually historical data will be recorded in the history table, and the main table will keep all most up-to-date things. So that actually is very good, especially when we want to query the data. So in this chart that, or in this, let's say, diagram that you can see here, two middle boxes are where actually I query my data. When I query my data, I just say select star from my table, right? When I insert, update, delete, merge, or bulk insert, or whatever, any data manipulation actually scripts would be exactly the same. So I don't have to change any update statement, insert statement, delete statement, select statement. I would work with the temporal tables in terms of data manipulation exactly as I work with a normal table. The only thing that is different is that creating this table, the structure of creating this table is different. So I have to consider that I need 3 more columns. I'll go through that later on. So my DDL script is different. And also, I have some specific features, specific commands in my select query that will give me some new insights. So if I just select a star from my table, I will get everything as up to date. What is the current records in my data? But if I want to see what was the data a year ago, then I have some options to say, for example, select star from this table for system time as of that specific date. So these are new features that are helping me to get some new insight out of my temporal tables. So how does this work? As I mentioned, temporal table is a regular table in your SQL Server. You can create that by even right-click in your Management Studio or with a script that I will show you later. There will be always two tables. The main table for keeping the most up-to-date records, history table that can be automatically generated, or you can either configure that yourself, especially when you are dealing with data warehouse. It is better to configure that yourself and build that yourself. And there are three mandatory columns in these tables. So this is a temporal table definition script. As you can see here, I have a department table, which has a department ID as a primary key, department name, manager ID, and parent department ID, right? So these columns are just normal columns. Then I have three columns, which are actually my mandatory columns for defining a temporal. And as you can see in my create table, I don't say create temporal table. I just say create table, right? But these three columns means that this is a temporal table or system version table. So these three columns are a couple of date time two columns, system start date and system end time. So that means anytime actually I insert a record, that record will be inserted at the time, at the current get date time of the server, and the end date will be year 9,999, month 12, date 31, right? So that means very far end date. And this will actually keep the changes like that. And any changes that happens, this will actually put an end date on the existing record, create a record with new start date from the current date. And the period 4 is a system time actually column that this also needs to be created. And at the end of create table, I say with system versioning on. This system versioning on means that I am creating a system version table. Please note that you can definitely, after setting a system version table after a year, a month, you can definitely turn that off with saying that alter my table with system versioning off. But for creating that, you would definitely need that. Right, so how temporal tables works in terms of changes. When you are applying any changes, these changes will directly go to temporal tables. So as a user, I pass my script, update, delete, insert, and that goes to applications or whatever to my SQL database, and I have two tables, one temporal table, another history table. So when I apply changes, if changes is insert, it will be automatically inserted in my temporal tables. If change means that I will have a record obsolete, like for example, when I delete a record, the record will be deleted from temporal tables or my main table, but it will be moved to my history table. So we will have actually definitely a copy of that in our history table. Or when I update a record, that record, the existing record will be moved to history table, and a new record will be created with the start date of just right now and end date at the very far end. The existing record that was in my main table before that update, when it moves to history table, will have an end date marked on it at the exact point of the time. So as a user, as a developer, I don't have to do anything. I just say update, insert, delete, and temporal table structure SQL Server will consider this all. When I query the data, from my front-end tool, if I select star from this table, I would only get data from temporal tables or my main table. That's when I say select star from department or whatever. But I do have some commands, as I mentioned before, like for system time as off or system time between, contained in, or those kind of things that I will let you know later on. If I use those commands, then I will actually have combination of data from my history table and temporal table. So I can, for example, see what happened in my data a year ago. That would be my query from here, and I will get a response from combination of data from history table and main table. I'll show you how the queries works. So that was a bit about how temporal tables work. I'll go back on a demo on that. Let's talk about a slowly changing dimension before. So a slowly changing dimension, if you are a data warehouse developer or an ETL developer or familiar with data warehouse structure, there are almost 6 or 7 types of slowly changing dimension. These 3 are the most common types of slowly changing dimension that you can see in this screen. Type 1 means that in your dimensions, you expect changes. For example, you are working on a retail business, retail store business. You do have a customer that your customer are in Arizona. His name is Joseph, and his country, his city is mentioned in your record. But that customer will move to Auckland, New Zealand at some stage because he see that Auckland, New Zealand is a very good place to live, so he comes to New Zealand. And the thing is that you don't want to lose those information, those sales information of him when he was in Arizona. Right, so you want to keep those as sales in Arizona, and you want to actually keep their sales tracking in New Zealand as well as the whole new record. So what we have in the slowly changing dimension behaviors depends on what we want to do. For example, sometimes you want to just update the changes. Let's say my customer name changed. It changed from Reza to something Mike or whatever it is. So I just update that change. So that means type 1. If you are not aware of what type of a slowly changing dimension you are doing, or you don't know what type is the default, I have to say default usually is type 1 because all of ETL processes usually update the existing record as it is. Type 2, which is also common, is talking about keeping historical information. So as you can see, in keeping historical information, I can have a start date and an end date. So each record has a start date. So for example, for this supplier, I have the supplier in the state of California, and from date 1st of January 2000 till 21st of December 2004, at that time, this supplier moved with the same information, as you can see, moved to another state, and I have that record as 22nd of December of 2004, end date nil. It can be either nil or it can be a very far end date like 9,999 or whatever, as temporal tables work with that. So I will have same supplier code, but supplier key is different, and that's the key that I will be using in my fact table. And my fact table then will exactly point that this customer is in actually made this sales transaction when he was in California or when he was in Illinois, right? Type 3, just to mention, type 2 is one of the most common types that you would use, especially when you want to keep track of changes. Type 3 says that you keep only a limited history. That means if you have your supplier changing state, you can have that as a separate column. So I have original supplier state and current supplier state and an effective date. That means that I have the current one and I have one step before. So if I want to keep 2 steps before, I have to add another column as well. Type 3, I haven't seen that be used too much, but if you only interested in keeping 1 step back history, that's an option. Now what is type 4? So type 2 is great type. The only thing is that it will affect on the performance because it will create historical records in the same table, and after a while that table will be bigger and bigger, especially if you have got a lot of changes. So type 4 created especially because of fixing that performance issue. So in type 4, I do have same structure. I will keep historical information, but in another table. So here you can see that I have my supplier in another table as a historical, and my current supplier information is in my supplier table, main table, and whenever I want to get the most current data, I just get data from the supplier table. Whenever I want to see historical, I go to historical table. Type 4 is great, much better than Type 2. The only problem with Type 4 is that it's more complex to implement, especially in the ETL side. And because you have to careful about quite a lot of things, inserting, deleting from two tables, syncing these two tables together. These are all you need to do in ETL. It's not, I mean, hard job to do, but it takes time to implement, and usually companies are not investing that much budget for just adding a bit of performance, which is a bit of shame. Fortunately, in in Type 4, we have a big surprise, which is temporal tables. Temporal tables helps us to build slowly changing dimension Type 4 very easily. I'll show you how that works. Type 4 pros and cons. It's much better in terms of performance. It's has a complex ETL, which in this session I'll show you how that can be easily done. Right. So let's go through the demo. Before going to temporal tables in action demo, I'll just show you some few slides about how that can be generated. So I can create a table in temporal tables like this. And as I mentioned, so I have three columns there. When I create that, my temporal tables will be automatically named like this, like MS SQL temporal history for my object ID of the main table. I'll show you how that works. I have these three mandatory columns that I spoke before, period for system time and to date time, two columns. And when I create that in my Management Studio, I will see actually my temporal tables as a system version signed like this, and my historical table as well. They will have the same structure with mandatory columns as well. And it is easy to create temporal tables from Management Studio, so you can right-click on tables, new system version tables, or you can write a script for that. If you follow creating system version tables like this from graphical interface, then this will generate automatically this script for you, and you can replace it with actually items that you want. Right. So when we generated that, if we want to query the data, if I just say select star from my table, I'll have the output like that. Let me show you how that works. So here is my Management Studio, and I have a sample database. This is SQL Server 2016. You need SQL Server 2016 for that, definitely. I have a department table. Here you can see that my department table is system version. And I expand that. Let me make it also bigger as well. All right. Control 4, I believe. Yeah. So here is my department table, and as you can see, under department table, I have another table. So this is my table system version. If I expand that, I have another table called MS SQL temporal table, temporal history for this object. This is object ID of the main table, right?
Reza, were you trying to zoom in a little bit? Because I don't think it did.
Pardon?
Were you trying to zoom in a little bit there? I don't think it did. I didn't get a zoom in. No, I didn't get a zoom in.
Oh, okay, right. So maybe that zoom thing doesn't work through GoToWebinar.
Well, people have a zoom for themselves. Oh, there you go. There you go. There we go. That's
okay.
There we go. Nice.
Okay.
Yep.
So as you can see, my columns are here. Oh, sorry. Are here. Sorry about my drawing. And this is my history table. And this is my main table at the first. My main table structure and history table structure are exactly the same. As you can see in this picture, I can either get data from history table or my main table. But let's get data from my main table first. So if I just come here and type in my query as select, let's make it bigger, select the star from department. So here is what I get. I get my department information with system start and end time. These are usually your system time. So when you show that in your application or in a customer-facing type of things in your front end, you probably just get rid of them and don't select the star. Right. So this is my department table. If I want to select from this system version, as you can see, I don't change anything. But let's say I want to see what was the status of my table, what was the data in my table for system time as of, and then I put my date here, let's say as of 2016, whatever, 02/19. I can also mention the time. That's 6 a.m. 6 a.m. If I execute that, now I can see that this is different. To show you how this is different, I'll run these two side by side. So here you can see I have my second result set here. This is my current data set. This is my current records. And the first data set is actually records that has been in my data, in my table at 19th of February of 2016, 6 a.m. Right. So I can see that I had a sales department that has been deleted for sure. I had a marketing department. I still have that, so that nothing changed on that. I had an IT department, and it has updated because the manager of that IT department was a manager with ID 10. Now it is a manager with ID 100. And I have a new HR department which was not there at that time. Right? So I can easily time travel with just a simple statement like that. Right? Or if I want to see the changes in my data, let's say I want to see changes for system time between two dates. So let's say between, let's say for example 2010, 01/01, and the date that I've mentioned here. So if I execute this, now I can see actually changes in that date, right? So I can see the changes, how the changes worked, and was that between that time or not. So if, for example, I can either change it to 13 and see that there was nothing between 2010 and 2013, but there was something between 2010 and 2016. So I can actually filter that data with a simple statement like this for system time as between, or I can even use for system time contained in. Contained in will actually mention those records that only has been deleted or updated, actually those obsolete records, right? So if I say contained in, this will actually make those records that has been obsolete from that time. I don't have any, but if I say, for example, from this time, from 19th of February of 2016 till now, what is the time now? 2016, 05/26. Here is New Zealand, that's the time, and it's 12/29 something, right? And this. Right, so I can see if there is any changes happening in that contained, deleted record after that time, right? So go back to my slide deck. Oh, not from the very beginning, sorry. Where am I? Okay, so as I mentioned, if I query the current data, I just select the star from department. If I want the data to be for a specific time, I can say for system time as of a specific date, and I can also try statements like for system time between this date and that date, and this will also show me some changes as you can see here. There are different actually statements that you can use. I've mentioned them in this table. So as of will bring the data at that specific point of the time for you. If you use from, start time, and end time, this will show all actually records versioned in that specific point of the time, and between that time and date will bring the historical records. Contained will bring those records that has been closed at that time between that period, right? And all will bring back all records, right? So temporal tables, pros and cons. It's easy to implement slowly changing dimension with them. I'll show you how that works. The cons is that inferred dimension member is not supported. I'll go through the demo first, and then I'll talk about what is inferred dimension member. So demo, I showed you temporal tables, so that's all okay. I'll go through the slowly changing dimension in SSIs. So you have probably seen that in my other demos of slowly changing dimension before. This is an example of applying a slowly changing dimension in SSIs. There are different ways of doing that. You might use merge statement, you might use slowly changing dimension component, which I don't recommend at all. It's very bad in terms of performance. You might use the third-party Codeplex tool for slowly changing dimension, which is good, or you might do it yourself like what I did here. So here in data flow, here in my package, I have a data flow task. This is a normal slowly changing dimension without temporal tables, right? The current state. So if I get data from my source table or whatever staging you might want to get data from, so that's my customer source table, then I check for new records in my destination them customer, and I check that based on my customer alternate key. That's the unique key of customer in my source system. If I could find that, then I fetch out customer key, and I rename that as an existing customer key. If I don't see that, then my lookup will result as a no match output, and I will insert that record in my destination with a new from date, right? New from date, that means this record has been started just right now, right? So that's when I can't find the record in my destination. If I can find the record in my destination, then I have to check for each specific column, I have to check are values of that column changed or not. For simplicity, this slowly changing dimension demo only checks for English education. So I can check that English education, is that changed or not. And my joining key is also customer alternate key. So result of this lookup will be, if it is matched, then that means I have no changes, so I don't have to do anything. If I have no match, that means I have to update. I have to apply update. If we are doing update in a slowly changing dimension type 2, here is my OLEDB command that I do have a command here which says update customer set to date to this specific date of right now for this current customer key. So I just update the to date of that, and I pass customer key to my input parameters. If you want to learn about more how this works, have a read through my blog. I do have some also videos about that. That's out of actually discussing details of this is out of time for this session, and this is not what we want to talk about mostly because this is the old method. After updating the existing record, then I have as an output a new record, and that new record will union with those non-matched, and I will insert them all with the new from date. Right. So that will actually apply SCD type 2 for my dimension before 2016, right? You can still in 2016 use this method, but there is a much better method for doing that. So I'll show you how in 2016 we can do that. So in 2016 we can do a new method. For 2016 I'll use merge command. There's no difference. You can use merge command for previous version as well, but the merge command in 2016 is much easier because I have to write a much smaller merge command to do my slowly changing dimension. So here I have a data warehouse underscore TMP. This is my temporal table data warehouse, and I have a staging underscore TMP as well. This is my staging database. So in my staging I have customer table and sales table, transactions and customer, and these will come to my data warehouse. Sales transaction will come to my packed internet sales, and customer information will come to dim customer. And as you can see, dim customer is the system versioned actually table. That means this keeps track of changes. If I expand that, I can see that I have a history.dim customer as well. You can see that the naming of this is different from the history table that you've seen previously. That's because I created that with a specific create table command that I'll show you here. So this is my create table command for dim customer. Create table, everything is as normal create table, just these parts. I have these 3 mandatory columns. I have to add them everywhere I want to have a system version or temporal tables. This is my primary key, nothing particular about that. And then I have this section. This section says with system versioning is on, which is exactly as it was in my previous demo. But here I say history table is equal to history.dim customer. So I have actually created that table before, and I use that here. Or I can create that when I run this query. So that's absolutely, when it comes to my historical table, I have quite a lot of flexibility. I can partition the table, I can do some creating that manually, or I can create that on the fly, or all those kind of things, right? So I have this table, and now what I have to do, because this table keeps track of changes, right? So I don't have to do it myself. I don't have to check if it is changed, then obsolete the first record, existing record, and create a new record. What I have to do is only check the data from the source table, sorry, source table was this one, from the customer source table, compare that with customer in the destination table, and update if it is changed, insert if it is not there, delete if it is in customer but not, delete if it is not in customers but in dim customer, right? So I do have a merge command here. This sounds to be a very big merge command, but it is not. If I just take out these for a moment, you can see that this is not a very big merge command. So what I do in this merge command is that I merge my data warehouse dim customer table. This is my target table, using my source table, which is customer from a staging table. I join that based on customer alternate key. When it is not matched, then when it is not matched, that means I have data in my source, not in destination. Then I will do this insert. So this is insert record into the destination, values comes from the source. So that's the whole thing is just an insert statement, because we do have quite a lot of columns, so that's a big one. When it is matched and English education is not the English education that we have in our target table, then what we have to do is to update the target table in English education. So I don't actually update end date, I don't create a new record. Temporal table will do all of the things for me, right? And when it is not matched by source, then I delete. That means the record is not in source, but it is in destination. And here is just an output for my own log that shows if there's any changes, just show me in this reporting window. So you probably won't have this in your ETL. It's just for my own life. So let's run it now. If I run it just right now, I would see nothing as a result of that because nothing has changed. Now, if I go to my source table, customer, edit, and let's say as an edit, I come here and change this particular customer English education field. I don't do other fields because this is what I've checked for. English education to be bachelor's. Another person from bachelor's to high school. Let me also delete a number of records. 3 records to be deleted. I can also create a record. I just copy one and paste it here. Let's specific characters for this, that just to be unique because this is our unique key. So I've inserted some records, updated and deleted some, right? Now if I go to my merge statement, which was very simple merge statement, and execute that, I can see these changes are coming through. So 1 as an insert, 3 records as delete, and 2 records as updated, right? So now in my customer table, if I go to my customer table and say select star from then customer, I do have the existing records here, 999 records, which is existing. To check that, is it existing or not, I can check for this new value that I just created. So if I say where customer alternate key is equal to this, and I do have this. This is just created, and you can see that system start time is just right now. Okay. Now I go back to one of the records that I have deleted. Oh, sorry. I don't have actually the key for deleted records. So for that, what I do is that I'll get distinct of the start time, system start time from my then customer. And that means this record is this time is the time that my record has been changed last. So I get actually my customer information, let's make it bigger, for system time as of this date. Let's check a minute before this time, right? So if I check this time, I do have 1001 records. And at that time, I didn't have actually this record. As you can see, this record was not there. Right now, this record is there. And also this happens on all changes as well. So for a change, for example, the record that has been changed, one of the records that has been updated is this one. So I can check this record. This record previously was this with the value of English education as bachelor. Right now, this record is still there. English education is high school. Usually you don't have someone from bachelor to high school, but this happens in my data warehouse and my demo. Alright, so I showed you how actually this can be done easily with a very small merge statement, and temporal tables will take care of everything, right? So that's one big main usage of temporal tables. I can go back any point of the time in my temporal tables. For incremental load, you may want to use temporal table for incremental load, but not for your destination table. Your destination fact table, if you apply temporal table, it won't actually help you in terms of incremental load process, because incremental load process is about fetching the change set right? So when you want to fetch changes, it's all about the source database, the source table. So if you have your source table, your source database in the SQL Server 2016 database, and you can enable temporal tables on that, then you can easily fetch the latest changes with queries like for system time contained in, and then you check from your latest ETL runtime till now, and you will have records that has been changed. You have to at least, you have to also add some more bit of statement here to get exact changes, but it is easy to implement. The one big thing more that temporal tables is really good with is actually ability to roll back. So when we are doing incremental load, when you do full load, that's not a problem at all. Every time you can do a full load again. But when you do incremental load, it is usually happens that people says, I want to roll back to that specific time. I want to roll back yesterday to see what was the data. Some corrupted records came into my data set and I don't want them to be there, so roll back to yesterday. Sometimes they say, okay, roll back to a month ago, sometimes a year ago. So I had a demo of implementing rollback without temporal tables with normal SQL Server database table. I've added 3 columns to that to do the thing, and now temporal tables are doing exactly the same. So if I have my fact table as a temporal table, then what I would have is that I can roll back at exactly any point of the time as I want, right? And it won't actually affect the performance of querying from my data warehouse, because when I query from my data warehouse, I just query from my most up-to-date records, which are only in my main table. If I want to roll back, then I will go to my historical table, right? And what I will have to do that time travel to roll back to any point of the time is just this simple statement here that says for system time as of that time and date for rollback, right? So I'll do a consideration slide and then we'll go through Q&A. So consideration, when you use that in the data warehouse, consider schema to put your historical tables there. Just don't leave them in your DVO schema or those kind of things. These are kind of some best practices to use that. Consider some proper namings for your tables instead of MSSQL underscore historical table for underscore object ID. That's not a good name. Put a proper naming, put in a proper schema like Historia schema, and be careful that temporal tables consider changes in all columns. When you do SCD and when you use your merge statement, only apply that on the columns that you want SCD type 4 or type 2 to be applied on. And performance is one of the things that still has to be considered. If you are just inserting data in your record, you won't have any specific performance problems because it's just a simple insert. If you are deleting and updating quite a lot, then you have to consider performance carefully. The thing is that 2016 SQL Server is not out yet, so we cannot say any word for sure that how this works exactly in terms of performance, but I will definitely post some performance things on my blog. Temporal tables has some limitations, and the limitations is that you must have a primary key, usually you have in your data warehouse. You must have those 3 mandatory columns that I've mentioned. History table by default is page compressed. Blob data types like text and text, like binary data types are supported, but never use this on those data on columns with those data types, because any changes will create a whole new record with that binary value, and that will make your database massive, quite slow in terms of performance. Historical tables should be in the same database. You cannot have that in another database. Indexed view are not supported. Truncate table is not supported. Drop table is not supported in a normal way. If you want to drop, you have to first turn off the system versioning and get rid of the historical table. Some trigger limitation also. This link actually will show you quite a lot of limitations that are available. These are limitations, but still temporal table helps a lot. In summary, I've talked about system version tables or temporal tables, which is, from my point of view, one of the best features in SQL Server 2016 for me as a data warehouse and ETL developer. You can have ability to time travel and do slowly changing dimension much easier. You need to do minor changes in your queries and in your SQL statement. Temporal table can be helpful for slowly changing dimension, for incremental load, and for rollback process. All right. Thank you. And these are links to study more. There is a 20-minute video by program manager of Temporal Tables. Have a look through that. That would be really useful. And some demos of this session on my blog and links to MSDN documentation. Thank you. Any questions, Joseph?
Yes. So you can hear me, correct? Right. Yeah, there were ones that were asked. I'm pretty sure some of them got answered, but let's just go ahead and quickly get to them. How many levels of temporal can SQL go back? Is it just the last change or all the changes over a time period? I think you kind of answered that, but if you would answer.
Sorry, what was the question? I cannot see the question here, so can you please repeat?
Okay. How many levels of temporal can SQL go back? Is it just the last change or all the changes over a period of time?
Yeah, all the changes over a period of time. It's just there is no limitation. The limitation is on the data that you have and from when you started actually loading data in your temporal table. So if I create my temporal tables right now, my history would be from now, right? So if I want to get back to history after in, let's say, year 2030, then I can go back only to up to 2000 down to 2016. But that said, if I have a history of my record somewhere else, not in a temporal table, somewhere else, I can build my history table with those actually historical log before. So history table is quite flexible for me. So I can transfer my data, history data into here, and then I can go back to 1990 or whatever my history log is.
Yep. Another question was, how much overhead is caused by using temporal tables? I think you kind of hit on the performance as far as 2016 hasn't been out yet, so I don't know if we can answer that, can we?
That's a good question. If it is insert, if majority of our work is insert, then performance would affect very low, very little, let's say 1%, because it will mostly work on only the main table. There won't be any interaction of historical table. The only thing is that when we do delete and update, especially update, because it will move that record, it will delete the record from the existing main table, it will create a new record in the main table and move that previous record into the historical table. This will take time, definitely. In terms of the exact percentage that I say, for example, this is, I don't know, 20% worse, 10% worse in terms of performance or whatever, I have to still check. I haven't had temporal tables on an actual data warehouse because it's not fully released yet. So after full release, fortunately, I would be able to make some performance checking on that and would put that on my blog.
Yeah, I would like to know how it affects the TempDB, if you use a lot of TempDB with that, or if there's a lot of logging involved. And I think everybody else would like to know. So another question: can you convert existing tables to temporal, or do you have to drop and recreate them?
If you have an existing table, you have to create a new table. It's not, as far as I know, I might not be right, I can check that. Okay. You have to create a new table because your data should come with the new structure. It should come with the system start date, time, those kind of things, start time, system end time. You can, however, create a new table and move data from your old table to the new table because you want to keep historical information over there as well, and move and configure it as you want, and after you make sure that this is working perfectly, then get rid of your previous table.
Is there a way to limit the table history, the version, so limit So can you define a limit on the version table history table?
Nothing I am aware of, because in the DDL section I can only define a history table. I can say system versioning on. What I can do is that if I don't want system versioning to be on at a specific point of the time, let's say my system versioning, my temporal tables was running for a year, now I want to turn that off because I think I don't need that anymore, right? So I can alter my table, say system versioning is off. So my data, my historical data will stay there, and from now on, no history will be stored anymore. I will only work with my main table. If I want history for back in the before a year ago or something like that, I can do that. And anytime I want to go back, I want to change back that system versioning to on, I can do that.
Another question, can temporal tables help recover data in manual error? So if you do like a bulk delete or a bulk update?
Yes, of course. The only thing is that for bulk delete and bulk update, I think there would be some performance effect on that, because delete and update would be, especially update, would be the most expensive task on a temporal tables, because as I mentioned, one record obsolete, another record created, the obsoleted record will move to historical table, but it is definitely possible to go back before that time or whatever.
We keep on getting a couple more questions here at the last second. So column store indexes, can you add them to temporal tables? Do you know?
I haven't checked that, so I can't say anything for sure. I'll check that and post that on my blog.
Also, can you specify a file group for the history table?
Sorry, what for history table?
File group, so you can specify what file group.
As far as I know, it should be on the same database. I think you probably can have that in different file group. I have to look at the limitations, not exactly sure, but I think it is possible.
Okay, so then just can you create a process to delete data from the history table when it reaches a certain age?
Yes, definitely. You can have a SSIS package running on a job schedule, or a simple SQL script running on a job schedule, and delete those part of data in history table. History table is like a normal table. You can delete from that normally, you can select data from that normally. So if you want, for example, to delete some records, you have to only delete those records that they're, let's say, for example, system end time is, let's say, before my particular date and time, before 5 years ago or whatever, then just delete those. Yeah.
So get one last one here, and a pretty good one. Would these temporal tables be useful in transactional databases, especially backups, where the scope is limited to SCD, slowly change dimension tables?
Definitely it can be helpful for applications, especially for applications, I would say, because in most of the applications, especially for some organizations, they are interested to know what were the data a year ago or something like that. So definitely that is useful for them. In terms of performance, as I mentioned, we have to check performance.
So if we go to the next slide, I would like to make sure that that people stay tuned. What's coming up next? Got data, go modern and monetize. Learn how to run Hortonworks as a service through Microsoft HCI from SEN. I would like at the last slide, I would like to also thank everybody for attending, and Reza, great job.
Thank you.
Definitely.
Thank you for everyone attending here, and thank you for Joseph and Elizabeth for hosting this session. It will be, I really appreciate that, and it was my honor.
Thank you.
Thanks.